Hello IP student. Today our topic is bitwise operators, and in this lecture we are going to discuss about two bitwise operators, especially bitwise left shift operator and bitwise right shift operator. Till now we already discussed some bitwise operators, but in this lecture our focus um, is to describe how bitwise left shift operator and right shift operator works. So let's start. What is bitwise operator? Bitwise operator are those operators which work on bit. Bit means 0 and 1. So this operator basically works on bits, that means 0 or 1. So that's why they are called the bitwise operator. Uh, and This is a bitwise left shift operator, and bitwise right shift operators. So these two operators will be discussed right now. Um, First of all, bitwise left shift operator. So what is bitwise left shift operator? The bitwise left shift operator basically shift shift the uh, bit in left direction. That's why it is called the bitwise operator. So let us take an introduction first. In Python part 5 we already discussed some operators, and these operators are arithmetic operator, assignment operator, comparison operators, logical operators, identity operators, bitwise operator, and membership operators. These all types of operators are already discussed in our previous lecture. And as far as bitwise operators are concerned, we discussed 4 operators regarding to bitwise category, and these operators are bitwise OR, bitwise AND, bitwise NOT, and bitwise complement, and bitwise XOR. So these basically are related to bitwise operator category of bitwise operators. These are binary AND, also called binary AND, binary OR, binary XOR, and binary ones complement. So these operators are already discussed in our previous lecture, and in this um, lecture we are going to discuss about bitwise left shift operator and bitwise right shift operator. So let's start. Bitwise left shift operator. The bitwise left shift operator, this is the bitwise left shift operator, shifts bits for a value by a given number of places left. So this is the sign of bitwise operator. It adds 0 to a new position. So at empty places 0 should be added, and this is the example of bitwise shift left operator. Remember that given number of places left, it is also very important, and always shift bits, it means 0 or 1. And third important thing is that adds 0 to new positions. So as far as new positions are concerned, 0 will be added. Now there are a small example here. You can see that 4 and then bitwise shift operator and then 2. Now there is a question arises in mind that 4 is not a binary number. Then how bitwise operator work on this? Actually, first of all, 4 should be converted into binary number. After that, 2 bits should be shifted according to the question, and shifted in left direction, because bitwise left shift operator works here. So that is 4 bitwise left shift, then 2, that is a question. So actually answer will be 16 after the execution of the program. Now one question is there that how 4 left shift 2 results equal to 16. First of all, 4 should be converted into a binary number. Then according to that binary number, 2 bits should be shifted at left hand side, and after that whatever we get the result in the binary form should be converted into integer number, and that integer number should be reflected as your answer. So after executing this program for bitwise left shift 2, then answer will be 16. So you can easily see that 4 bitwise left shift 2, when we want to convert 4 into binary number, 4 is a decimal number of course, then answer will be 100. Answer is 100. 100 means 100, not 100, because 100 is a decimal number. 100 is the answer to convert 4 into a binary number. And then we actually shift 100 to two binary places, and left direction, two places, then it will equal to actually 10000. So shift it two places in left hand side. You can see that it is shifted to places in the left hand side. So this will be 10000, and these are the places by which number is shifted two places. And when we convert 10000 into a decimal number, answer is 16. Answer is 16. So 16 will be the answer after execution of that statement. I think the concept is clear to all of you. If you don't know how to convert a decimal number into binary number, there is a small example here. You can easily see that 17 is given here, and 17 is a decimal number. We already know that 17 is a decimal number. And if you want to convert this number into a binary number, actually, we cannot say that a particular number is a decimal number or binary number. Number is basically defined using their notation, and here 17 is a decimal number. If nothing is defined, then by default number is to be considered as a decimal number. In this case 17 is a decimal number. To define decimal number, subscript we write 10. So 17 is a decimal number, and to convert decimal number into binary number, there is a method of shown on a screen. First of all, uh, write just 17 and divide by 2, and then we can easily see that when we want to divide 17 by 2, then 8 is the answer and 1 is the remainder. So write 8 just below 17, and 1 just right hand side, just left hand side of that 17. So you can see that in our screen. You can easily see that 2, 17, 8 and 1, and this process is going on until 1 or 0. We get 1 or 0, it means a number less than 2. So again 8 will be divided by 2, and answer is 4, remainder is 0. Again 4 is divided by 2, answer is 2, remainder is 0. Again 2 is divided by 2, answer is 1, and remainder is 0. So finally we get a number in terms of a binary. You can see that, and always read this number from downward direction, upward direction. So start from the last element, which is 1 in this case. So the number is 1 0 0 0 and 1. So this is the number, and this is basically the number which is a binary equivalent to number 7. You can easily see that. Always start from the last number. When we divide 2 divided by 2, then the number is 1, and it cannot be again further divided by 2. So we start this number 1, and then after all the remainder in downward direction to upward direction, and 0 0 0 1, and this is the binary equivalent regarding to the 17. You can I think now you can easily convert a decimal number into a binary number. See that 17 divided by 2, again 8, then 1 is the remainder. Again divided by 8, answer is 4, and then remainder is 0. 2 4 divided by 2, answer is 0, remainder is 0. Then 2 again divided by 2, 1, and then 0 0. So the cursor just follow the cursor position, and then just write 1 last number, and then 0 from downward to upward direction, then 0, and then 0, and then 1. So this is the binary equivalent of 17. Binary equivalent of 17. Similarly, this process is going on in this question. First of all, 4 should be converted into a binary number, and equivalent of 4 is 100. You can convert 4 into binary number. 100 is the answer, and after left shift 10000 will be the answer, which is equivalent to 60. Now there is another question raised in our mind, that 10000 is a binary number and this will be converted to a decimal number. So what is the process to convert a binary number to a decimal number? So we already discussed how to convert a decimal number into binary number, but if you want to convert a binary number into decimal number, there is a process, and let us discuss this process. I think all of you are very aware to this concept, but here I just give you a brief introduction how to convert a binary number into a decimal number. So always remember that when you shift left, then two decimal places are filled with 0 in case of left shift, as you seen on a screen. So after left shift 100, the answer will be 100 and 00. So these are the two positions which we get after apply left shift operator here. So 10000 the answer after shift. And why we left shift only two places? Because in question 4 left shift 2 is given. In case of 3 places will be number will be shifted at 3 places, will be shifted up to 3 places. So 2 is given, so shifting of 2 decimal places is given, and if 3 is given, then 3 will be the answer. So now let us check by how to convert binary number into decimal equivalent. Just write the binary number, whatever is the binary number, just write it after giving some space between each and every bit. Then follow the procedure. First of all, just write bit one by one, and then multiply first bit which it has unit place. These are the bits. You can easily see that 101010 is a number. This is not number which is given on the question. This is another example just to show the functionality of the binary number. So just write 0 first and then multiplied by 2 power 0. Then write second number 1 and multiplied by 2 power 1. It means increasing order. Then third number 0 and multiplied by 2 power 2. Again power will be increased by 1, and fourth number is 1 and multiplied by 2 power 3. Again there is increment of power. So we start from 2 power 0 and going on from left to right and multiply each bit by 2 power n. Here n is the 2 power n plus 1. N is the position of the number. And after that add all these numbers, and whatever you get is a decimal equivalent corresponding to that number. That is called the binary number. That is called the decimal equivalent to that binary number. So now you can easily see that if you want to convert a binary number to a decimal number or decimal number to a binary number, there are two different processes. In binary number, actually we follow the process of division and divide a number by 2, and in decimal to binary to decimal conversion, we actually multiplied by 2. So this is the basic difference, and always remember that at unit place we multiplied by 2 power 0, and power is continuously increasing as far as we shift from left to right. So whatever we get after adding all these number, we get the desired number, that is decimal equivalent to that binary number. Now our second example is bitwise shift right operator. Bitwise shift right operator. So the bitwise right shift operator is just opposite to that of the bitwise left operator. This is the sign of bitwise right operator. You can easily see that, and the working is just opposite to that of the bitwise left operator. It means it just simply shift the bits in a right direction in right hand side. So in this, the main disadvantage is that some bits are lost, so number is totally changed whatever we get after the shifting. So the main disadvantage of this is that some bits are totally lost. We lost our bits. So let us take an example first of this number. This is an example again for right shift true, for again right shift true. So first of all, the procedure is same. After executing that statement in interactive mode for right shift 2, wait a minute, you can easily see that this is a right shift operator for right shift 2, and we get answer 1 after executing that statement. Answer is 1. And why we get 1? Because first of all, 4 is to be converted into binary number, and we already know that for binary equivalent of 4 is 100. So 100 should be shifted 2 places in right direction, in right shift operation performed on 100. And after shifting the 100 and 2 places at right, what we get is 1. So 1 is the answer when we right shift 100 in right position or direction. Now number is 1, which is a binary number, but when we want to convert this number 1 into a decimal number, its the decimal equivalent is also 1. So answer is 1 after execution, after the execution of that statement. You can easily see that 2 bits are shifted at right places, and so the comparison is 100 right shift 2. Hundred is right shift 2 because equivalent of binary equivalent of 4 is 100, and then answer is 1 in binary number, and 1 is also, when we convert 1 into decimal number, its equivalent is also 1 in decimal. So its binary equivalent is also 1, because it is multiplied by 2 power 0, and 2 power 0 multiplied by 1 is equal to 1 into 1 equal to 1. So decimal equivalent is 1. One which is marked here is a binary number, and 1 we get as a desired result is actually a decimal number, which we get after the conversion. Python actually calculate all these numbers. This is the functionality to, this is basically is for us, not for computer, to calculate binary number or or left shift operation or right shift operation. So if there is a question asked related to this in our examination, that after left shift or right shift operation, what is the answer, so you have to apply this logic. Until and unless you don't know how to
convert this number, you cannot get the answer. Here 1 means, as I told you, 001, it means it is a binary number after whatever we get after the right shift, and which we after the conversion we get 1, which is a decimal number. Now I think it is clear to all of you. Now last topic related to Python operator is Python operator precedence. Python operator precedence means says that order of the operators. So there is a particular order which should be followed when we use when there are many operators in a single statement. So as we know that in mathematics we learn about the formula Bode-Mass rule. In similar manner, Python operators, there is also precedence or a formula. So first of all we solve bracket, but after that bracket sign or parenthesis sign, use just solve exponential sign, and after that the priority is binary bitwise negation, a bitwise complement or binary operator. Here one thing is there bitwise plus x or plus minus x, these are the unary operator, not binary operator. So plus also works as a unary and binary. The operators which we work which the operators which require two operand is called the binary operator, and operate and operators which required only a single operand is called the uni operator. So plus behaves plus and minus both behaves like the unary and binary operators. So uni plus uni minus and bitwise negation are the have second priority. Next addition and subtraction, and then left shift right shift, then bitwise and bitwise or bitwise XOR, bitwise or, comparison identity not and a not. So this is the basic, this is the precedence of different operators, you can see that. And the last as far as the last the lowest precedence is of equal or is of assignment operators, means at last we perform assignment operator, which is actually not given in this question. Always remember that multiply, divide, floor division, modulo division, all these have same precedence, and they comes before addition and subtraction, as like in math according to the Bode-Mass rule. So almost Bode-Mass rule is follows, but since there are some new operator which is not a part of mathematics, so we have to learn this most of the time, or we can say that Bode-Mass rule is also follow in Python programming language. So first of all exponential, then uni operator, then plus minus, and then uni operator, then division, multiplication, and then plus minus. So arithmetic operator have greater precedence than comparative and logical operators. Now let us take another concept regarding to the Python programming, and this is all about dynamic typing. Dynamic typing, I think all of you are very familiar to this concept, and we use many number of times in our program, but we don't know exact terminology regarding to this, what we say this. So it is dynamic typing. Let us check what is dynamic typing is. If we want to give a value to a number, suppose x is equal to 10, it means 10 is provided to x, there is assignment operator of course. And if we want to print this value x, print x, then what we get the result 10. And after that if we get x is equal to 10.5, then we want to execute this number, then 10.5 will be the answer. We can say that 10.5 override the previous value of x, that is x. And if we give again a value of x is equal to a string, that means suppose a string hello world, and if we want to print that statement hello world, then what we get the answer is our hello world. So basically we give three different types of values in the program, and the variable is same. First of all we give a integer type of value, then float type value, and then a string. And throughout the program we can see that a value of x is changed according to the condition given or according to the value given. It means whatever we type the value of x within that program, value of x is changed according to that first of all x have a integer value, and then float value, and then after string value. So we can easily we can execute this program. So first of all, let us check what is the answer. You can easily see that the answer is before execution, save this program, give a name to this program, and mark a symbol.py to save the Python program, and that is the answer: 10, 10.5, and hello world. So x have three different values at three different point of time. That is also called the dynamic typing. This is the concept which is known as dynamic typing. So dynamic typing is nothing but only the typing of different types of values throughout the program to a same variable, and Python accept all these values. That is called the dynamic typing. This type of concept is not introduced, not is a part of other languages. When you declare when you declare a variable of particular type, this always shows the behavior of that um, data type throughout the program. But in Python programming, it is not so. Throughout the program, if you want to change the type of the type of the data type of the variable, then it is also possible. And we can easily see that here we give three different types of values to x. So first of all, x is an integer number, after that x is a float value, and after that we give a number of we give a string type value. And when we print these three statement, then different types of value will be printed throughout the program of same variable. So that is called the dynamic typing. Now let us revise it again. These are the different values provided to x. X is equal to 10, print x is equal to 10.5, print x is equal to hello world, print x. So in this program variable, there is only single variable x, and there are three different types of values provided to x. At first line number 1, x is equal to 10, integer type value. At line number 3, x is equal to 10.5, it is a float type value. And line number 4, x is equal to hello world, which is a string. And when you want to print all these statement regarding to this, first of all x will be printed, after that 10.5 will be printed, and after that hello world will be printed. And why it is so? Because it is a concept related to dynamic typing. This whole process is called dynamic typing. Dynamic typing means type the different type of value to a variable, and it will make no error in the program, and it accept all these values. First of all, x is equal to 10 is provided, then it is not, there is no compulsion then x should always be an integer value. If we change the data type of the x throughout the program, it will be changed without any error. So x is an integer value first, in first case. X is 10.5 in second case, and x is equal to a string hello world in third case. And these are the three different types of value. Yet the program will be executed successfully without any error, because Python accept all these numbers, or Python accept all these types of values throughout the program. So whenever there is a single variable, and when we want to provide different types of value to this variable, Python receive all these values without showing any error. This concept is called the dynamic typing. You can see the output. I already explained the output here, but let us see the output again. This is the output: 10, 10.5, and hello world. And why these are appears in three different lines? Because by default separator is /n, means next line. So these are not appear in a single line. First 10 will be printed, after that 10.5, and then after that hello world. So hello world is a string. These are the three different types, and that this concept is called the dynamic typing. So many number of times it is asked in examination, explain the concept of dynamic typing, or what is dynamic typing. So just write the definition of dynamic typing, after that taking an example. This example is sufficient to explain the concept of dynamic typing. And So just write the definition of dynamic typing and explain the example related to dynamic typing. That is sufficient. Now I think all these three topics which I discussed in this lecture, um, I think all of them are clear to all of you. So first is bitwise left shift operator. Just perform it, uh, taking two or three numbers and perform a left shift operator and right shift operator and check whether the answer is same or not by applying decimal to binary and binary to decimal conversion. So thanks for watching this video.